Hi folks, thanks for being with me for this tutorial about persisting in-memory data for later usage. I'm Nicolas Frankel and I work at Hazelcast in the position of developer advocate. This tutorial comes from a Stack Overflow question, and the question is: once a Hazelcast map entry has reached its time to live, how can we still keep it in the database or file or whatever, because we still need it, but it's not necessary in the cache anymore. In order to answer this question, I will use the use case of an e-commerce shopping cart. So imagine that we need to design such a cart. At first, it's very easy to use the database. We already have tables for products, for orders, for users. So we can use one such table, let's say a cart table, to store what is in the cart of the customer. So when he adds an item to the cart, we can insert a euro into the cart table with his customer's ID and do the same for every customer. And we can also remove or update the quantity. So it's the most straightforward path. However, the problem with this approach is that it doesn't scale. If your eShop becomes successful, many users will come to use the application. And so you will notice that the database becomes a bottleneck, because every time a customer interacts with its cart, then you will need at least one round trip to the database. So this back and forth requests and response, there will be a big problem regarding the performance of your application. The next step is to move away from the database and put everything in memory. It can be any data structure you want. It could be an array list, it could be a map, it could be anything. So I have a little demo to show. And I've created a Spring Boot application, and it can be a Java EE application, can be any kind of application. It's just that Spring Boot makes its things very straightforward. And here I've created a cart class, which basically is just a thin wrapper around an array list. And this works pretty well. However, the big issue with this approach is the list is bounded. You can put items in the list and you don't know how many items you have unless you call the size, and it can grow unbounded like that. So if you have an unbounded number of customers who have an unbounded number of cart items in their lists, then you can have troubles with your memory. When you reach this point, in general, you go to a dedicated in-memory data grid such as Hazelcast. So Hazelcasts manage that things for you. You can set a cap on the number of items in any data structure, and then you can have rules to remove items when you are trying to get over that limit. For example, as was mentioned in the question, you can have a time to live that say, hey, if the item in this data structure has been there for more than 10 seconds, 10 minutes or whatever, then you remove it. You have also other rules such as least recently used or whatever. So this is managed for you. This is automatic, so you are sure you will never run into in-memory error. So let's switch to Hazelcast in our application. And now what I have is I have a cart service. So this cart service is just like a facade to an Hazelcast instance. And if I run this application, I can try to log in now, and I can put stuff in my cart, put multiple items, and it works as expected. Now comes the real issue. It's not because you have a bounded number of items that you can put a limit that will remove items automatically that you shouldn't clean up yourself. So for example, one very good example is when the user logs out, we want to clean up after him. So basically we want to remove everything that has been put in the cart. So how do we do that? Then we can switch to this version, and then we can have here a listener, which is a simple HTTP session listener. And when the user logs out, because when the user logs out, we forcibly destroy the session. Then when the session is destroyed, we can check if the user has been assigned a cache, and if yes, then we can remove the cart. Now comes the real business requirements. And the business requirement is, hey, we still want to keep the cart if the user didn't purchase. But as I mentioned before, if you keep everything in IMDG, then it will grow and grow and grow until you reach the limit, and then you will remove items. You don't know which one. It will be based on their TTL or the list recently used or whatever rules you configured. But basically, we cannot comply with the business requirement. Now comes the answer to the question. We want that when the user logs out, we want to put everything into the database. So the content of the cart will move from IMDG to the database. This code is very, very easy to do. So now, when the session is destroyed, we will get its content, and we have created a dedicated repository where we will put all of the cart rows. Now, if we use the application again, from a user point of view, you won't see any difference. Let's say like that. Now, if we log out, and we come back in, we still have the cart. The difference is that the cart now has been restored from the database. So it was removed from the IMDG, put into the database, and when the user logs in again, then we get everything back into IMDG. And here is the cart restore service that does the exact opposite of the cart removal listener. Is basically, we find all the cart rows that were stored from this user, and we put it into IMDG again. This is very, very good. This is what we just did. We persisted the cart. However, it doesn't leverages the power of Hazelcast API. So here, the application will remove things from IMDG and will put it into the database itself. However, we can do better. We can use Hazelcast API so that automatically, when the application removes things from IMDG, we can here have a listener that will do the database insertion. And this is how it works. Now we have this entry removal listener, and so this entry removal listener will listen. It implements the observer pattern. So every time you remove an entry from IMDG, then it will store it will do whatever you want. And in that case, actually, what we want is to store the card's contents. So now it's the same code as before. It just has been like moved from the session listener to this entry removal listener. And here it is used there. So we just need to create a bean of this type, and we need to register it to the card, and it's done. And at this point, we still have the same behavior as before. I will log out, I will log in, I will add stuff to the cart, and I will log out. And again, when I log in again, I still have my items. So thanks for your attention. I hope you find this video useful. You can find the blog posts about it on Hazelcast blog. You can find the code repository so you can play with it by yourself. And of course, don't forget to follow Hazelcast's Twitter for more information. Thank you very much for your attention.